For the given circuit, I want to find both Thevenin's equivalent and Norton equivalent circuit seen at terminal A and B. So basically, I want to find when I want to find Thevenin's equivalent circuit, I need to find the open circuit voltage here, and when I want to find Norton's equivalent circuit, I want to find the short circuit current here. So, and then the equivalent resistance is the same. The resistance, the Norton's resistance or the Thevenin resistance will be the same, the resistance that is seen from here. So for the Thevenin circuit, let's do the open circuit. Let's find the open circuit voltage here. So what I will do, I will do some source conversion here for Thevenin's equivalent. So there is a current source and a parallel resistance, so I will convert it into a voltage source and a series resistance. So it will become like this, and then this one there, and this one is like that. So it's there. So I am doing this part for finding the open circuit voltage basically. So to find the Thevenin's equivalent circuit. So this value is, so this is the terminal here and this is the terminal here. So the voltage value of the voltage source will be 1 times 6, so 6 volts, and the resistance will remain 6 ohms, and here it's 14 volts, this is 14 ohms. So now in the next step I will add these two voltages, so it will become 20 volts here and then 20 ohms there. And what I will do in addition is I will convert this current source and the parallel resistance into a voltage source and a series resistance. So I will do this conversion of this current source as well. So it will become like this, the polarity will be downwards and like that. So this one, the value will be 3 times 6, that's 5 ohms, so 3 times 5, that's 15 volts, and the resistance will be 5 ohms, will remain 5 ohms like that. So I need to find VOC here. So I can see that a series current will flow like that, and the value of that current, if I called I here, will be, the voltage sources are adding each other, so that will be 20 plus 15, 35, and the sum of the resistances will be 25, so that will be 7 over 5. So the voltage drop across 5 ohms will be V5, if I write, that will be 7 over 5 times 5, so that's 7 volts. So 7 volts drop in this direction, and then here it is plus minus 15 volts, so VOC will become minus 8 volts. So that's the open circuit voltage. So my Thevenin's equivalent circuit will be like this, minus plus 8 volts, and the resistance seen here, if I look at this, maybe I will look at whatever, I can look at this circuit here, open circuit, the resistance seen here with the sources being inactive, so both the voltage sources will be shorted, so the resistance will be 20 here and 5 here, that's this one short circuited, this one short circuited, so basically 20 parallel 5, and 20 parallel 5 will be R, 20 times 5 over 20 plus 5, so that will be 4 ohms. So this is the Thevenin's resistance, so that's 4 ohms. This will be the same for Norton circuit, so I won't do the resistance part anymore for the Norton circuit. So what I will do, I will try to find the short circuit current, and in order to do that, I will start from here. So I will start from here in this circuit, so I will rewrite that circuit. So here it was 20 volts here and then 20 ohms there, and this one I will not convert, so I will leave it there. So this is 3 amps and this is 5 ohms, and I need to find the short circuit current. So basically the first step I have done similar as I did for the Thevenin's equivalent circuit, but then I have not converted this part, so I have kept it like that. From here what I will do, I will reconvert this voltage source and the series resistance into a current source and a parallel resistance. So that will be like that, and this one downwards as it was in the original circuit. So this is 3 amps 5 ohms, and this is the short circuit current ISC, and here the value of the current source will be 20 over 20, so that will be 1 amps, and this will be 20 ohms. Now all I need to find is to find the current, short circuit current here, and since these two parallel resistances are shorted out by this short circuit, the current will be very simple. So this current will make a current of 1 ampere flowing downwards and 1 amps, and this current source will try to flow a current of 3 amps in the upper direction, in the upwards direction. So the short circuit current will be, if so basically it will be upwards 2 amps. So 2 amps upwards, that's how it will be. So the Norton equivalent circuit will be like that, and the resistance will be in this case also 4 ohms, and the value will be 2 amps. So this will be the Norton equivalent and this will be the Thevenin's equivalent. Now let's imagine that we have a, let's say another 4 ohms connected in the terminal A and B. So 4 ohms resistance is connected connected at terminal A and B, and we need to find what is the current flowing through that using Thevenin's and Norton's equivalent circuit. So in this case, if this is my terminal A and B, and I am connecting the load which is 4 ohms, and let's see what will be the current flowing here. So the current flowing will be, I will be here 8, the voltage, value of the voltage, and the resistance is 8 as well, because this is 4, this is 4. So I will be 1 amps, and that will be upwards. So 1 amps flowing in this direction. So that will be the value I am finding using Thevenin's equivalent circuit. Now let's see what I get from Norton's equivalent circuit. I should get the same current. So this one is 4 ohms, and in this case what's happening is, so the Norton's equivalent circuit, actually the current will be downwards. Did that wrong here. So it will be downwards because when I found the Norton equivalent current, I saw the current was going upwards. So when I draw the circuit, it has to go downwards like that, so that in this branch, short circuited branch, the current go upwards. So it will be like that. So I have a 2 ampere current source and 2 parallel resistances, 4 ohms, 4 ohms. They are of same value, so the 2 amps current will be divided in half. So the current through our load 4 amps, so this is A, this is B, will be 1 amps upwards. So it's the same current as I got from Thevenin's equivalent circuit. So yeah.